Alright, fellow stargazers, welcome back. In our last cosmic conversation, we grappled with the monumental challenges that stand in the way of interstellar travel. But now, let's shift our focus from hurdles to hope. Because the brilliant minds of our species aren't just acknowledging the difficulties, they're actively conjuring up some seriously ingenious solutions. Get ready to re-engage your mental engines, because we're now blasting off into the realm of potential propulsion technologies for interstellar travel. We're talking about going way beyond the tried-and-true chemical rockets of today, folks. We're venturing into the realm of technologies that could, one day, potentially shrink those interstellar voyages from millennia down to mere decades. So, what are the most promising pathways to the stars currently being explored in labs and the fertile imaginations of sci-fi thinkers across the globe? We'll explore everything from souped-up nuclear engines to antimatter power plants that sound like they were ripped straight from the bridge of the Enterprise. Is this all just wishful thinking, or could these be the real blueprints for our future journeys to distant suns? Let's find out. 1. Chemical rockets, why they're grounded for star hopping. Let's begin with the foundation, chemical rockets. These are the workhorses of our current space endeavors. They're responsible for launching astronauts to the moon, powering the International Space Station, and deploying countless satellites into orbit. They operate by burning fuel to generate thrust, and they've served us incredibly well for exploring our solar neighborhood. But when it comes to interstellar distances, unfortunately, they hit a fundamental wall. The bottom line, my friends, is that chemical rockets are just inherently too slow for the vastness of interstellar space. Even the most advanced versions currently in development, like SpaceX's Starship or NASA's ISS, as awe-inspiring as they are, couldn't propel us even a tiny fraction of the way to the nearest star within a single human lifetime. And the sheer amount of fuel required? Forget about it. A chemical rocket mission to another star would necessitate carrying billions upon billions of tons of propellant. It's a logistical nightmare of epic proportions. It's akin to trying to sail across the entire Pacific Ocean in a bathtub, technically possible, perhaps, but utterly impractical and likely to take, well, forever. For shorter cosmic hops, like a journey to Mars, chemical rockets are a viable option. But for truly venturing beyond our solar system, we desperately need something exponentially faster, something that can bridge the light-year gap. 2. Nuclear engines, a quantum leap in efficiency? Alright, so chemical propulsion is a no-go for interstellar voyages. What's the next rung on the ladder? Nuclear engines. Now we're starting to talk about a serious upgrade in power and efficiency. There are two primary types of nuclear rockets that have been seriously considered. Nuclear thermal rockets, harnessing atomic heat. These engines function by using a nuclear reactor to heat liquid hydrogen to incredibly high temperatures, which is then expelled to create thrust. Think of it like a super-efficient steam rocket, but instead of fire, you have the power of controlled nuclear fission. NTRs boast about twice the efficiency of chemical rockets and could potentially cut the travel time to Mars in half. It's a significant improvement, showcasing the raw power of nuclear reactions, but even with NTRs, a journey to Proxima Centauri would still stretch into thousands of years, making it more of an interstellar snail mail than an express service. In nuclear pulse engines, a bold and controversial concept. This is where things get interesting. The concept involves detonating small nuclear bombs behind the spacecraft, using the shockwaves to propel it forward. Crazy, right? This idea was actually explored in the 1960s under Project Orion, a US research program dedicated to investigating nuclear pulse propulsion. Theoretically, it could potentially accelerate a spacecraft to an astonishing 5 to 10% of the speed of light, making interstellar trips feasible within decades instead of millennia. Imagine the sheer audacity of such an endeavor, harnessing the power of atomic explosions for peaceful exploration. The major drawbacks, however, are significant. The inherent dangers of detonating nuclear devices in space, the immense political sensitivities surrounding such technology, and the fact that it's currently prohibited by international treaties. Nuclear engines, whether the more refined NTRs or the audacious Project Orion concept, represent a significant step up from chemical propulsion. They might even serve as crucial stepping stones towards true interstellar travel. But ultimately, they might not be the final destination. We need to set our sights even higher, towards the power source that fuels the stars themselves: fusion. 3. Fusion propulsion, powering starships with starlight. Fusion, the very process that ignites our sun and countless other stars across the cosmos. It unleashes phenomenal amounts of energy by forcing atomic nuclei to combine, releasing vast quantities of energy in the process. Many scientists believe that harnessing fusion power is the key to revolutionizing space travel. It's often called the holy grail of energy generation, and for very good reason. Fusion rockets would tap into these incredibly energetic fusion reactions to generate immense thrust. They could potentially achieve speeds of 10 to 20% of the speed of light. Let that sink in for a moment. Suddenly, interstellar missions become conceivable within a human lifespan. Imagine reaching Proxima Centauri in just 20 to 40 years. That's a timescale that could allow individuals alive today to potentially witness humanity's arrival at another star system, a truly profound thought. Projects like the Direct Fusion Drive, DFD, and ongoing research at institutions like the Princeton Plasma Physics Laboratory are actively working to develop fusion-powered spacecraft. This isn't just science fiction dreaming, folks. This is real science, real engineering, real progress being made right now. The biggest hurdle, of course, is that we haven't yet managed to build a commercially viable, sustained fusion reactor for power plants here on Earth. Let alone miniaturizing and ruggedizing one for use in a spacecraft that needs to operate for decades in the harsh environment of space. Controlled fusion is an incredibly complex scientific and engineering challenge. But once we finally crack the code, fusion rockets could very well be one of our best bets for making interstellar travel a reality. Think about it, taking the power source of the sun, shrinking it down, and strapping it to the back of our starship. Minor engineering challenges aside, of course. For antimatter engines, bridging the gap between science fact and fiction. If you're a fan of Star Trek, you've undoubtedly heard of antimatter engines. Warp drive, anyone? Well, this isn't just the stuff of science fiction anymore. Antimatter engines are a genuine theoretical possibility, albeit an incredibly ambitious one. It represents the most potent theoretical propulsion method we currently know of. When matter and antimatter collide, they annihilate each other completely, converting 100% of their mass into pure energy. Let me repeat that, 100%. That's vastly more efficient than any chemical or nuclear reaction we know. In theory, antimatter rockets could potentially reach speeds approaching 90% of the speed of light, making interstellar travel within a few decades a very real possibility. The implications are staggering. The ability to traverse interstellar distances within a human lifetime would fundamentally alter our understanding of our place in the cosmos. But here's the monumental challenge, the cosmic elephant in the room. Antimatter is incredibly difficult to produce and outrageously expensive. Right now, producing even a single gram of antimatter would cost trillions of dollars. Trillions. And storing it safely? That's an equally daunting task. If antimatter comes into contact with any normal matter, boom, annihilation. We would need unbelievably advanced, almost magical containment systems to prevent this. But if humanity ever manages to figure out how to produce antimatter cheaply and store it safely, antimatter engines could very well be the most powerful rocket technology ever conceived. It's a long shot, a very, very long shot, but as explorers, we have to dare to dream big, right? 5. Laser sail propulsion, a glimmer of near-term possibility? Now for something that might be a bit more within our reach in the near future, at least on a smaller scale. Laser sail propulsion. This is emerging as one of the most exciting and potentially feasible ideas for taking our first tentative steps towards interstellar travel. Here's the core concept. Instead of carrying vast amounts of fuel, you attach an enormous, incredibly thin and lightweight sail to a spacecraft. Then, powerful lasers, either based on Earth or perhaps in orbit, are fired at that sail, using the pressure of the light itself to push the spacecraft forward. Think of it like sailing a boat, But instead of wind, you're harnessing the focused energy of lasers. Because the spacecraft carries no fuel for propulsion, it can theoretically accelerate to incredible speeds, potentially reaching up to 20% of the speed of light. It's an elegant solution, leveraging the power of light itself to overcome the vast distances of space. There's even a real-world mission under development right now utilizing this very technology. It's called Breakthrough Starshot. Funded by visionary billionaire Yuri Milner, this ambitious project aims to send tiny spacecraft, affectionately called starships, to Proxima Centauri using powerful, ground-based laser arrays. If successful, these microprobes could potentially reach our nearest stellar neighbor in just around 20 years. 20 years. That's the fastest interstellar travel time ever seriously proposed. It's truly mind-boggling to consider. Of course, this exciting idea still has its challenges. We need to build those incredibly powerful and precise laser arrays, and ensuring the stability and integrity of such a massive, delicate sail in the harsh environment of deep space is no small feat, but laser propulsion represents one of the most promising near-term technologies for taking our first, albeit robotic, steps towards the stars. 6. The wildest ideas when physics gets flexible? Now, let's venture into the realm of truly speculative, mind-bending concepts, ideas that push the very boundaries of our current understanding of physics. Some scientists, and certainly countless science fiction writers, propose the possibility of effectively breaking the speed of light barrier, or at least finding clever ways around it. We're talking about warp drives and wormholes. Warp drive, the Alcubierre drive. This fascinating concept, proposed by physicist Miguel Alcubierre, suggests that instead of a spacecraft moving through space faster than light, we could potentially warp the fabric of space-time itself. Imagine space being compressed in front of your spacecraft and expanded behind it, creating a kind of warp bubble that allows for faster-than-light travel without technically violating Einstein's theory of relativity. Ingenious, right? Almost too good to be true. And perhaps it is. The major stumbling block? It theoretically requires the existence of exotic matter with negative mass energy density. Negative energy. We have absolutely no idea how to create such a substance, or even if it truly exists in a form we could manipulate. It's a beautiful theoretical construct, hinting at the potential flexibility of space-time itself, but the practicalities remain firmly in the realm of the unknown. Wormholes, cosmic shortcuts through the fabric of reality. Wormholes. The very name conjures images of instant travel across vast cosmic distances. Sounds like science fiction magic? Perhaps. But theoretically, wormholes could be actual shortcuts through the fabric of space-time, acting like tunnels connecting two distant points in the universe. Imagine stepping through a doorway and instantly appearing light years away. Instant interstellar travel. Awesome. Also, maybe entirely imaginary. Wormholes are currently purely theoretical constructs. And even if they do exist, we have absolutely no idea how to find them, stabilize them, open them up, or safely traverse them. Wormholes? Right now, they remain firmly in the realm of science fiction. But hey, as we've seen throughout the history of science, never say never, right? The universe is a profoundly weird and wonderful place. So, when we look at the current landscape of potential propulsion technologies, what are the most promising contenders for getting us to another star within the next century? If we're talking about reaching another star system within the foreseeable future, the most realistic options currently appear to be: Number 1. Laser sail propulsion. This technology holds the potential to send small robotic probes to another star system within a few decades. Keep a close eye on projects like Breakthrough Starshot. They could be our first interstellar scouts. Number 2. Fusion rockets. If we can successfully harness the power of fusion, this could be a robust and efficient way to transport larger payloads, including human crews, to other star systems within a reasonable time frame. Fusion power, the energy source of the future, and quite possibly the interstellar future. Number 3. Nuclear pulse propulsion. Project Orion, a blast from the past, literally. This older idea might still be viable in the long run, but the significant political and safety concerns remain major hurdles to overcome. And then we have the more futuristic, long-shot candidates, antimatter, warp drives, and wormholes. These are truly amazing concepts, but they come with incredibly significant scientific and engineering challenges. If we ever unlock the secrets of antimatter production and storage, near light-speed travel might become a reality. And if we manage to truly understand and manipulate the fabric of space-time, well, perhaps warp drive will one day warp from science fiction into science fact. Right now, interstellar travel remains a dream, a grand aspiration. But it's a dream that scientists and engineers around the world are actively working to make a reality. Maybe, just maybe, one day humans really will be traveling between the stars as casually as we travel between cities today. The journey is long, the challenges are immense, but the potential rewards are literally cosmic. Thank you for joining me on this exhilarating exploration of the potential technologies that could one day propel us to the stars. If you enjoyed this journey into the future of space travel, please like this video and subscribe for more captivating insights into the wonders of science and the universe.